Okay, just for the sake of time, I'm not going to collect all the data points. However, let's try it out. Some people, even if it's up, sine A, what is it?
62.
Sine A is 62?
Oh, sorry. Sine A is 0.883.
883, okay, and little a is?
35.
35. Sine B?
0.951.
0.951.
28.
28, and?
0.719.
And?
37.
37.
I'm
going to say that you switch these two sides.
Wait,
sorry, man.
guys, stop.
No. Can you check?
Yes, I'll check.
No. Sine B.
Yeah.
Are you sure you matched it with the opposite side? Because from the numbers that you gave me, I feel like sine
I'm
B.
100% sure.
How did you do that?
He was 28.
Wait, John, do you have to sign the,
Huh?
And it's
what is it?
An angle B at 72.
just tell me the number.
From 0, it's actually 75. I think it's
Oh, yeah.
75.
Yes.
Yes.
Okay, I got them wrong. I got them wrong, everyone.
No,
I got them wrong.
Okay, 0.719, and this one was what? 0.9 something, right?
0.951.
951.
Mr. Kim,
Yep.
I'm confused about his lengths are 35, 20, and 37. Mine are like 7.7.
No, for her, she did it in millimeters.
Oh, look at me.
Wait, I didn't know that. Okay.
She did it in millimeters. She counted every single notch, that's all. Okay, so with that, I need some other people.
Yes. Do you want me to say like mine? So
Yeah.
sign A.
What's your sign A?
0.89.
Okay.
And then 0.882.
88.
Okay.
Oh, no, wait. This is 0.88?
Yeah.
And?
And 0.81.
0.81. Can you give me the size as well?
7.6 for A.
7.6.
7.4 for B.
7.4.
And 7.2 for C.
7.2. Okay, and one more.
Yeah.
One more. Sorry,
0.99,
0.99.
0.88,
0.88.
0.53,
0.53.
3.8,
3.8.
3.4. No, that's 3.8 and then 3.4.
3.4.
1.9.
0.9.
1.9.
1.9. Okay, those three people. Divide this number by that number. Divide this number by that. Divide this one. I want three numbers here.
I already
Three
know.
numbers here. Go for it.
3.84,
3.84.
3.86,
3.86.
3.58.
3.58.
So it should be the same what I measured.
That's okay. Human nature. It happens. Come on us. Okay, what were your numbers?
Okay. So for the first one, it was 39.64.
39.64.
For the second one, it's 38.94.
94.
And for the third one, it's
Hopefully 30 something.
it's 38.9.
Or 38.
0.91.
What am I doing? 3.86. 38.91. Okay, that's pretty good.
Mine.
From I got it wrong, everyone, to pretty good. Yes.
Mine were exactly when I divided it. I think 0.108.
0.18.
0.108 again. And
108. Okay.
Yeah, same next.
0. Wow, that's exact. Last one, Rory. Have you gotten it divided yet?
Yeah, I'm just doing the last one.
Yeah, for sure. But I think taking human error and our ability to measure using these primitive tools into account, I think we've noticed that it's happening every single time. Can I convince you that we can sort of agree together that it's happening pretty close every single time? Right? Shameless plug into science. If I were to try and prove this happens every single time, what would I have to do? If I want to prove it happens every single time, you would have to do it with every single triangle out there. Do you want to do that? Probably not. However, in the world of science, although we can't prove it's 100%, if it happens every single time that you try it, a theory slowly morphs into a
Fact.
something of science.
A law. Sine law.
So, can you prove gravity? Not really, but it happens every single time. So we call it law of gravity. You know what I'm saying? So because it happens every single time, we can establish the sine law. A ratio between an angle and its corresponding side is always equal to an angle with its corresponding side, which is equal to the angle and its corresponding. The three ratios are always going to be equal. Always. And that's a sine law. So you can write it as this. I'll give you a summary sheet in just a second. So three ratios, the three fractions are equal to each other, or you can write it as this, because it should still give you a same comparable ratio, right? If it's 2 over 1, 2 over 1, 2 over 1, 1 over 2, 1 over 2, 1 over 2, it still gives you a comparable ratio. Yes, question?
So little a, so like the side length.
Yes,
and
corresponding side to angle.
those two should always be the same number.
Yes, of course, because we've established we were trying to
Yeah.
pair them together. It has to be corresponding angle, which means, it's a very good point, the only time you can use sine law is if you have
Three.
the what?
Three sides.
No.
I keep trying to.
The only time we can use sine law is if we
Have 3 of the 4.
the only time we can use a sine law is if we have those matching side and angles. What if I don't give you in a question a matching side and angle?
Can't do it.
Then we can't do it. So here's a disclaimer, and again, I'm gonna write this down, but if you wanna write in your scrap piece of paper, if you wanna add this, I'm gonna add a disclaimer to this, okay? Disclaimer. What do we need? One of the 3 side angle pairs must be provided. It must. And if you don't, well, you can try it. I guarantee, in fact, I dare you. Try using the sine law, and you'll find that none of these fractions are complete, and you're like, what the hell, I can't do it. Okay? It's not because Mr. Kim says so, it's because everyone has tried it, and they're like, it's impossible. I have a fraction, I can't do it. Yes?
So if it gives you one, then every single one, and one's the same one.
The too long didn't read version? Can't believe I'm doing this. It's going to be filmed. Oh my goodness.
What is it? What are you doing?
This is the summary version where if you don't pay attention, you can pay attention to this. If you lost your way throughout this entire lesson, just pay
I
attention.
found my way back.
The only way we can use sine law is if we have an angle and its corresponding pair. Long story short, sorry, relax. If I have an angle, and a side. In other words, angle, side in a clockwise rotation. Or if I went counterclockwise, what does it spell? Angle, side, or side, angle. Do you notice how this angle and its corresponding side was given?
Yes.
So in this situation, you can use sine law. So angle.
Oh, you don't need 3.
Side.
3 you want 3 that.
As long as you have it, well, you can find this, can't you?
Yeah.
Right? So technically, you can find it. Here's another situation where you can use sine law. If you're given angle, and then a side, and then an angle. So ASA, and if I do clockwise angle at side angle, it's still ASA. How does that work?
You can find that angle.
We can find this, right? I'll write because this can be calculated. Okay? You can find that. Therefore, if you have this one, you technically have a side angle pair. And lastly, Yes, you can laugh it
Two
off.
sides. You can do two sides.
Two sides and an angle. What does that spell?
Two sides. SS. Oh, or ASS.
Angle, side, side. So if you have this, yes, laugh it off, whatever. Or backwards, SSA, you have a matching angle side pair. Now this is important, as inappropriate as this is. When you get to grade 11, this particular scenario opens itself up to an unnecessarily complex possibility. The idea of knots, regular acute, button, obtuse, triangle. You don't have to worry about it. If you're curious, come talk to me. But I'm throwing it out there because I want you to actually remember in grade 11, this particular scenario will get a little harder. It's a bit of an ass of a problem. Get what I'm saying? Okay? These three, so this is angle, side, angle. This is angle, side, side. Please excuse my terrible writing, I'm just rushing it. All three situations provide a matching angle, side,